Hello everyone, welcome to second part of the video on important lab Viva question for the subject Analog and Digital System Design Laboratory. This Viva questions are mainly focused on the second experiment called Design and Development of Oscillators. Okay, there are three types of oscillators and there are 15 questions. I request everybody to must and should watch this particular video. Definitely you can score better for Viva. The first question related to Colpit oscillators. So we'll have brief discussion on only the Viva question, important thing. So I'm not going in depth. So at least if I give some guidelines, I think we can do better. What is the purpose of Colpit oscillators? So first you understand the meaning of Colpit oscillators and the circuit diagram, everything you need to have a good idea. The Colpit oscillator is designed to generate the sine wave, okay, at a specified frequency using LC tank circuit. Okay, that is circuit diagram you have to remember. Definitely you can speak up in a proper way. This is regarding the Colpit oscillators. Okay. Second question is, if I talk about the second question, explain the principle of operation of Colpit oscillator. How does Colpit oscillator operate? So remember that the Colpit oscillators make use of LC tank. Okay, separate design is available where the capacitors in series are parallel to an inductor. That is the way how it is configured. It operates by positive feedback. Remember that to sustain oscillations at frequency determined by the tank circuit components. That is a brief idea about the Colpit oscillator. That LC tank design, that is very important. How it is connected, you have to remember by referring the circuit diagram so that you can convince. If external examiner asks you to draw the diagram, you can draw the diagram at any point of view. Even I have explained the demonstration. I request you to watch the video which I already composed in my channel. What are the advantages of Colpit oscillators over other type of oscillator configuration? See, the merit includes the high frequency stability. That's a plus point. Then even design is not that much complicated. Use the formula. You might have remember the formula and a good frequency response. So that is, these are the major advantages of Colpit oscillator configuration. Another question is, how does the frequency oscillation depends on the components in oscillator? Mainly, LC component, right? LC filter. The frequency of oscillations is primarily determined the values of both inductor and capacitor. That LC tank design, that is most important. Okay, there are formula to compute that. If you want, you can convince those formulas and stuff. So fifth question says that. What is the fifth question? Please read. What is the role of transistor in Colpit oscillators? Why it is transistor is needed in Colpit oscillator? You are using the BJT, no? Why it is needed? Yes, the transistor amplifies the signal from the tank circuit and provide necessary feedback to sustain the oscillation. That is why we require transistor. It will act as an amplifier basically. Okay, so that is regarding the Colpit oscillator. Now we'll discuss about the crystal oscillator. Second type of oscillator is actually called a crystal oscillator. You might have heard about the piezoelectric effect. If I talk about the crystal oscillator, you should explain about the piezoelectric effect. Okay. What is the significance using crystal oscillator circuit? Crystals, we are using a crystal. After high stability and accuracy in the frequency generation due to the inherent piezoelectric principle. That is why we are using the crystal oscillator here. So it works based on the piezoelectric effect. So non-electrical quantity that is going to be converted into electrical quantity. There is a piezoelectric crystal. If you apply the force, you are able to get either voltage or current. That is called a piezoelectric effect. So you are capable of explaining those piezoelectric effect in brief. Explain the working principle of crystal oscillator. Yes, a crystal oscillator works based on the principle of piezoelectric effect, which I mentioned just now. The crystal oscillator vibrates mechanically when subjected to an electric field, generating the stable frequency output. Okay, that is a feature, speciality of the crystal oscillator. Next is actually, we can explain what are the advantages of crystal oscillator compared to other type of oscillator. The advantage is it is more stable. Okay, stability compared to Colpit oscillator, it is more stable. Even accuracy is actually high. Low phase noise compared to other type of oscillator. There is no external circuit is required to reject or mitigate those external noises. That is a plus point. Then question number 9. Please read the question number 9. What does the frequency of oscillation related to crystal parameters? Okay. Then the frequency of oscillation determined by the cut and dimension of the crystal. So it's based on the crystal which you have opted. Higher overtone modes can also be utilized for the frequency multiplication. So these are the importance of like crystal and crystal frequency of crystal. The question number 10. Please read the question number 10. what measure can taken to improve the frequency stability of a crystal oscillator? So what measures can be taken to improve the frequency stability? So the thing is, you can use the temperature compensation. Then proper shielding, EMI shield you can use. Careful layout design, which you can improve the frequency stability. These are the basic necessary things you can make out for the crystal oscillator for improvement. These questions are more than enough with respect to crystal oscillator. Now I'll be discussing about the RC phase shift oscillator. So you can get so many questions from RC phase shift oscillator. A few of the questions will be important questions will be discussed in this session. RC phase shift oscillator. Please read the question now. What is the principle of operation of RC phase shift oscillator? So RC phase shift oscillator use the phase shift network. You might have remembered the diagram RCC like this kind of diagram RC. Okay, RC network you might have remembered R1 C1 R2 C2 like that. So likewise 3 RC circuit will be there. One RC circuit makes 60-degree phase shift. So 60 into 3 means a 180-degree phase shift. Understood or not? It comprises of RC, then to produce 180-degree phase shift at the desired frequency. Okay, so that is the peculiarity of RC phase shift oscillator. Please make a note of this. Okay, you may get a question related to how it is getting 180-degree phase shift. Please justify. How is the feedback achieved in RC phase shift oscillator? Is it positive feedback or negative feedback? So that you have to justify it. A feedback is achieved by feeding the portion of the output signal back to the input to appropriate phase shift, typically using an amplifier stage. So that is the way how we are going to provide the feedback in RC phase shift oscillator. Next is, you can read the question. Yes. What determines the frequency of oscillation in RC phase shift oscillator? The frequency of oscillations is mainly determined by the time constant. RC is actually called a time constant, no? RC, yeah, RC value. So T is equal to tau is equal to RC. While designing, you might have used the formula. Now we'll move on to another question. What are the advantages and disadvantages of RC phase shift oscillator? The pros are simplicity and a low component count compared to other type of oscillators. The drawback is it includes low frequency stability compared to other type of oscillator. That's the major setback of RC phase shift oscillator. You are supposed to explain the drawback of RC phase shift oscillator. So now we'll move on to the last question of this session. So please read the last question. How can frequency stability improve in the RC phase shift oscillator? What to be done for improving the stability? Because it is having less stability. High frequency components, provide the temperature compensation, careful design. These things, if you do it properly, definitely we can ensure high frequency stability. Because the structure is very simple and you can make use of that. But the stability is consistently poor compared to other type of oscillator. That is a major observation which we can make out from RC phase shift oscillator. I think if you refer these 15 questions, that is a lot more sufficient for cracking the Viva in a easier fashion. If you are going for like a core company jobs, you go for in-depth. But for lab and all, this is more than enough as per my experience. So let me know if you have any further queries. I'm very happy to answer back. Any other suggestions you can ask with me. I can modify my teaching learning methodology. Thank you so much for watching this video. Happy learning and all the very best for